Okay, we're moving on to NBT6. I have a multiplication problem on the board, but NBT6 is division. However, we want to drive home the idea of what division is using multiplication to just make those ties together. First, I always start by saying, class, division is repeated subtraction. Same way that multiplication is repeated addition. Now we're going backwards. So you could say, hey, how fast can we count by nines or by threes to get to this number? So if you count by nines 3 times, 9 plus 9 plus 9, or if we count by 3 9 times, 3 plus 3 plus 2 plus 2 plus 3, 9 times, we get 27. I'll just write this here in the corner. Now we're going to go backwards. So you can also put 27 divided by 3 equals something. We all know it's 9 because we just did that connection. But now we'd be minusing by 3 as many times as we can before we get to 0, which would be 9. You could also write 27 divided by 9 equals something, and we know it's 3. And just again tell them we're going to minus by 9 as many times as we can before we get to 0, which is 3. Just trying to drive home that point that it's repeated subtraction. Now, when we do this, again, the place value way, I like to do the backwards area model. So with multiplication, we drew a box. Division, we're going to draw a box. I'm going to draw this box. Now my box has that bottom part you're used to seeing, let's say 3, and then we had, let's say 3,427, and it looked like this because it didn't have this line. And you're like, oh yeah, I know how to do that. You can also maybe have written, we divide, we multiply, we subtract. Oops. Some people have their little catchphrases like dirty monkeys smell. Sometimes there's a B for bring down, so dirty monkeys smell bad. Daddy, mommy, sister, brother, whatever of those things, you can write that up here so that the kids can remember. But again, I'm going to use that place value aspect. So I'm going to close the box and draw my lines to show, hey, we're still going to stick with that place value theme that we kind of work with. And so let's start with it. How many times does 3 go into 3? We're only going to focus on this box. That way kids don't have to look at all these numbers or all those zeros or anything like that. Only looking at this box, which in this case is the thousands box. How many times does 3 go into 3? Once. We put that 1 up there. Next step is multiply. 3 times 1 is 3. Still in this box. Everything's lined up. Next step is subtract. And we got 0. Now in this case it's 0, but most of the times if it's not 0, I said we cannot leave this box until it's 0. If it's not 0, we would move it over here. In this case it is, so we cross that out and we're done with the thousands place. We're going to move to the hundreds. 3 divided by 4. How many times can we count by 3s to get to 4? 1. Again, 3 times 1, 3. We subtract, we get a 1. So this is a perfect example. We cannot leave this box until it is 0. We cannot divide anymore, so we bring down, or in this case, we bring over. So this would now be 12. How many times does 3 go into 12? 3 goes into 12 4 times. 3 times 4 is 12. We subtract, we get 0. Cannot leave the box until it's 0. It is 0. 3 goes into 7 twice. 3 times 2 is 6. We subtract, we get 1. We cannot divide anymore, and there's nowhere else to go. Now, for some of you that may be 5th grade or 6th grade teachers, and you understand that we're going to eventually add a divisions place, this is where it's really cool if they start to understand this aspect, because we could technically put a decimal here and move that over. So that's where I kind of like this way and add those aspects just to help our upper grades colleagues to kind of just already have those things in place, and the kids just have to quickly add it on. But that would, for now, in 4th grade, would just be a remainder. And this would be our answer.